All right, I'm having to break this video up. I talked 20 minutes and I only got to 3. So, part 2, I'm going to assume that you watched part 1. All right, we get to 4. Okay? 4 is now the first multiple of a number. 4 is now the first number that is 2 plus 2. It's the first time that you have a sum that doesn't involve 1. And it's also 2 times 2. It's the first time you have a product. It's your first composite number. It's the first time you have a composite that doesn't have, it's the only time you have a product that doesn't have a 1. So 4, he is now different than your 1, 2, 3 starting point. 4 is now, okay, like, I'm even. I'm based on a 2. 2 has built me. It's like Pokemon, okay? 2 evolved into a 4. Okay? So 4 is also a perfect square. 4 is a perfect square. It's a 2 by 2 square. That makes 4 special. Your first multiple, not a 1. 4 is stable. 4 has a terminating point in its decimal form. 1 over 4 is now 0.25. I don't know how well it shows up. Okay. It's terminating. I wrote these on here. They're probably too small for you to see, but I have the actual decimal, or the fraction. So when you get to 4, it's now terminating, which makes it stable. It's another, like 1 and 2, it's a terminating number. It's also the foundation of your first cube. That makes it special as well. So it's kind of interesting. You watch how, like, 1's like, okay, what do? I become a 2. All right, well, what can I do with this? 2 multiplies himself by 2, and he gets you to your first square. Because what we're going to see is that when 4 multiplies himself by 2 again, we're going to get to our first cube. All right. So 4 also has 90 degree as its interior angles. That's another thing I forgot to go into with 3. 3's interior angles of its triangle form is 60, which is so 3, 6, 9 click. I'll get to that with 6, but 3 and 6, they're already associated with each other. Anyway, so. Yeah, 4 is pretty cool. 4 is pretty cool. We move up into 5. Now, 5s, they're the loner. 5s don't really hang out with anybody. They don't have a lot of friends. 5's best friends are 2 and 0. Okay. 5 doesn't have any friends except for 2 and 0. 2, they get along with every even number out there. 2's just, they're friends with everybody. 5's, they're a loner. They don't hang out with anybody except for 2 and 0. Because as you'll notice, the multiples of, like, 2 are in blue, right? So 2, 4, 6, I know it's in green, we'll get into that. 2, 4, 6, 8. We now have 4 even numbers before we hit 10. 3s. We now have 3 multiples of 3 before we even hit 10, right? So if you paying attention to, like, the colors, each one of these has multiple friends in our first set between 1 and 10, right? 1, he hangs out by himself because everything is 1. He's the potential. 2 has 4 friends. 3 has 3 friends. You get to 5, his next friend is 10. 5 doesn't, he hangs out with the 2, but 5s are just kind of weird. They're half of 10, which is what makes them special, is that they're stable. I'm going to keep using that word. They're stable. They're terminating. Okay? 5's decimal form is 0.2. like I said. So if you look, 5, his decimal form, 1 over 5, is 0.2. 2, his decimal form, 1 over 2, is 0.5. Because 2 and 5 hang out with each other. They're buddies. Alright. He's the first odd building block. All of your money, besides a penny, all of your money is based on multiples of 5. The nickel, the dime, the quarter, the 50-cent piece, and the dollar, the coin, they're all multiples of 5. Because 5 is a stable number. You can build on 5. He's the first one that he is the most stable number. That's why we have 5 fingers on our hand, is because it's a stable number. It's the most stable number, basically, besides like 2. But that's why 2 and 5 hang out. Okay, if you watch my next video into my version of math, we'll understand why 2 and 5 are such best friends. Anyway, 5 is the pentagram. That's his gram version. And the pentagon is his gon version. Again, these are just terms I'm using. His decimal form is 0.2. The squares, he's not a perfect square. He's got 4 squares with an extra, because you'll see each odd number just kind of has this extra one attached to it. 5 doesn't hang out with circles. 5 doesn't hang out with circles or squares. How weird is that? That's what I mean. He doesn't really fit in. He doesn't have a lot of friends. 2 is friends with 4. 4 is friends with 8. 3 is friends with 6 and 9, because you see how they all have circles. But 5, he doesn't have any square friends or any circle friends. He's just kind of there. 5 now has multiple products of different, or sums, multiple sums. 1 plus 4 and 2 plus 3. But he is prime. He's our second odd prime number, which makes him special. 3 is our first odd prime. 5 is our next odd prime. So we're still building, right? 5's interior angles for his pentagon is 108 degrees. So each time we look at the gon version of each number, we're going to watch its angle get bigger and bigger and bigger. 3 starts with a 60-degree angle to make an equilateral triangle. Squares start with 90-degree angles to get us to a square. Your pentagon is now 108 degrees. They're getting bigger. Okay. 6. 3 times 2. So here we go. We got that 3 energy. We got that magic energy, right? Coming through. 3, 6, 9 are in their own clique. Okay, this is high school, right? 3, 6, 9, they're, I don't know, the mean girls. They're the art kids. You know what I mean? They have their own clique now because they don't like to hang out with even numbers. 6, he's like the diplomat. 6 goes between even and odd, but 6 has more of a foundation in being a multiple of 3 than a multiple of 2. And I know that sounds weird, but 6 is more closely associated with a 3. Alright. 6 is your first mod 5 number. So 6 is the first number that you can't count on one hand. I can count 1, 2, 3, 4, 5. How do you get to 6? I now need a second hand to get to 6. He's your first mod 5. In tally marks, 1, 2, 3, 4, 5, 6. So 6 is the first time that we have something that's 5 more than. It's your first mod 5 number. He makes him special. 6 is your first perfect number. So I don't know if you know what a perfect number is, when the factors, not including itself, equal the same as the sum. So the factors of 6 are 1, 2, and 3. 1 plus 2 plus 3, not including 6 itself, because the 6 and 1, 2 and 3. 1 plus 2 plus 3 equals 6. And so, just like prime or composite, perfect is another characteristic of a number. And 6 is your first perfect number. It said that God created the world in 6 days and then rested on the 7th, right? Well, it didn't take God 6 days because that's how long it took him. He did it in 6 days because 6 is a perfect number. There's some kind of quote. I'm not saying it right. There's something like that. 6 is your next building block of a circle. 60 degrees. Because you can have a 30, 60, 90 triangle. So 6 is interesting because he has a squared off. He's even. So this square is actually 2 times 3. So 6 is kind of squared off. He's even. But he's also associated with circles as well. So 6, he likes to hang out with both. He likes evens and he likes threes. And we now have 3 different sums that can get us to 6. 1 plus 5, 2 plus 4, and 3 plus 3. 6 is also composite because it has more than one factorization. 1 times 6 and 3 times 2. So it's composite. Then we get to 7. I can't even start with 7. 7, man, he's like that trust fund kid. He don't fit in anywhere. He's better than everybody else. 7 knows he's better than everybody else. God rested on the 7th day. You know what I mean? It's like, he's angelic. He's like an angel floating down the hallways. He floats. He doesn't even walk. You're like, dude, he like shows up to school in like a Mercedes. And everybody else is driving Toyotas, and this guy shows up in like Ferraris. Bro, do you really gotta rub it in our face how like different you are? 7. He is different. Out of all the color coding on this whole thing, how many of these are orange? Just 7. He isn't a multiple of 2, and he isn't a multiple of 3. He is the first number that is not a multiple of anything that we've built so far. He refuses to fit in. He's different. 7 hangs out with 3 and 2. The first 2 primes, he's friends with 3 and 2. He kind of hangs out with them. But those are the only people that can tolerate 7. You want to know how fucking special 7 just has to be? So we've got the heptagram, right? A 7-pointed star. And now we have the heptagon, the 7-sided geometric shape, right? So we've been watching our interior angles as we've been going up the numbers. Interior angle of 3 is 60. Interior angle of 4 is 90. Interior angle of 5 is 108. Interior angle of 6 is 120. What's the interior angle of 7? It's an irrational number. He can't even just be rational like everybody else. This is the first, besides 3 representing a circle and circles being defined by pi. So 3 can be kind of the first part. Anyway, 7 is the first time that we have a number that shows up with an irrational number in his definition. All these other numbers, you can define these by fractions. The interior angle of a heptagon cannot be defined by a regular fraction. It's 5 pi over 7, or so I've read. So, when we're watching, 7 just doesn't fit in. Look how special I am. I can't even have a rational interior angle like the rest of you guys. Fucking 7, dude, I'm telling you. And so, as we're watching our decimal forms, like 2 is terminating, 0.5. 3 is an infinite, 0.3 repeating. 4 terminates again. 1 over 4 is 0.25. 1 over 5 is 0.2, terminating. Okay, so we have terminating and non-terminating. 6, he's an even number, but he hangs out with 3, so his decimal form is actually infinite. It's 0.16 repeating. So 6, that's what I mean. Like, he wears a face like he's even, but when you get down to his bare bones, he's an infinite number. He's a circle more than he is a square, because he has an infinite repeating decimal. But like the repeating decimal on 3 is 0.33333333333333333. So it's like, okay, 3, you're so proud to be a 3 that your repeating decimal is just 3s, because when we're starting with creation, 1, 2, 3, your repeating decimal can't be anything but a 3, because there are no other numbers but 3s. You get to 6, your repeating decimal is 0.1. All right. 66666666666666666. So 6, he's like, boom, look at me. Like, I'm gonna put a 1 in front, and then I'm gonna be a repeating decimal for infinity of 6s of myself. So 3 has a repeating decimal that is himself, 3s. 6 has a repeating decimal that is himself, 6s. 7? Nah. He is the first repeating decimal that is not himself, but it's also not the same number, because the repeating decimal of 66663333, no, 7's repeating decimal, 142857. 142857, 142857, 142857, 142857. He now uses 6 numbers, perfect number. 7's repeating decimal is 6 numbers, and then it just repeats those 6 numbers for infinity. 7 doesn't want to fit in. No matter what you do. In all of this, like, 7 just doesn't fit in. He's better than everybody else, and he knows it. He's prime. Of course he is. He's a 7. Of course he's got to be special. You know what I mean? So 7's prime. He's got some sums. Nothing really special about him. Or not in that way. That's the only way. That's the only way out of all of this, that he's somewhat normal. That brings us to 8. Now 8, we're in high school. We're in school still. So 8, he's the football player. He's like a senior. No, 8's not a senior. He's a junior. Okay? We've been like moving up since 6th grade up to like graduation. So we've got 2s have friends with all even numbers. 3, 6, 9, they're in their own clique. 5, he's a loner. He hangs out with 2 and 0, and that's it. 6, again, 3, 6, 9 clique. 7, doesn't fit in with anybody. 8, all right. 8 is very special. He's that junior, so he started at 6th grade, and now he's a junior in high school, and he has a very stable future ahead of him. He's going to college. He knows it. And he's looking at a very stable life. I'm going to keep using the word stable. 2 is stable. Its decimal point terminates. 4 is stable. His decimal point terminates. 8 is stable. His decimal point terminates. And he's our first cube. Boom, look at 8. It's like, okay, we started as a 2, and 2 was like, okay, I want to have a happy future. So 2 built a 4, right? And 4 is like, okay, we're getting pretty stable. Well, what's 4 do? 4 doubles himself. Boom, he becomes a cube. Oh, like, he's building. He's growing. Good for him. And as he moves forward in life, he's just going to keep building a steady foundation and a steady future. Because look how stable a cube is. Like, that's your first Rubik's Cube, a 2x2 cube. Yeah. So 8 is technically the second cube. I'm sorry, because 1 is the first cube. But 8 is a cube. It's our next cube, built off of 2s. So 8 is also, the cube is your first platonic solid. No, I think that's wrong. I think that your triangles are your first platonic solid. So I'm sorry. Triangles are, the tetrahedron is a platonic solid. 8 is a cube, is a platonic solid. It's another characteristic. There's only 5 platonic solids in the universe, and they build up our entire universe. There's another whole video I can get into about platonic solids. 3 is a platonic solid, and 8 is a platonic solid. Look at me, we're special. So 8 is the 4th even number. That's saying something. He's a multiple of 2, and he's stable. So you can see the way that I'm drawing these is with the points, 1 point, 2 point, 3 point, 4 point, 5 points, 6 points. You just do a triangle, like 3, but you do a triangle inside the triangle to indicate 6. Because he has 3 points and he has 6 points. So I can just start drawing. Up here you can see, we can just start using these symbols instead of numbers. Anyway, that's a video for another time. 7, heptagram. 8, he's now a cube inside of a cube. He's a square inside of a square is what I meant to say. We now have an octagon. Again, his interior angle is rational again, because 7 is the only irrational one. So we're at 135 degrees. He's a multiple of 2, so he's square. The cube. 4 plus 4 gets us to 8, so he's easy to remember. And he's also composite. So we've moved out of primes for now. You get to 9, and he is back in your 3, 6, 9 click. You know what I mean? 3 times 3. Look at 3. I'm going to multiply myself by myself. Gets you to 9, right? So 9 is in the click. He's the basis of the right triangle, 90 degrees, which all trigonometry is built on right angles. So 9 is now the godfather of trigonometry. Yeah, we have an entire study of mathematics based off of what a 9 can do with a circle. He's pretty special. Like 3 started out, and he's like, okay, I'm the first building block of a circle. 6, a 30, 60, 90 triangle. Once you get 3, 6, 9, once you get to 90, boom, you have trigonometry. 3 times 3 is now the father of trigonometry. He's the last digit before 10. So like 1 is the first digit after 0. 9 is now the last digit before you reach another 0. That's pretty special. He's like the senior. He's about to graduate. You know what I mean? And he's also a square. He's the first 1 is a square. 4 is a square. And now 9 is your next square. That makes him pretty special. He's an odd square number. And he's composite. He's special, but he knows he's special. He doesn't need to prove it. The decimal form. So it's kind of funny because the decimal form of 3 is like 0.3333. And the decimal form of 6 is like 0.166666. 9, he's like, I remember back when I was in 6th grade. I remember when I was a 1. So 1 divided by 9, his decimal form, is 0.111111111. 9, he's like, no, I'm cool. I know who I am. Because, if 9 were proud, like the 3, 1 over 9 would be like 0.9999999, But he's like, no, I'm going to give 1 the credit. 1 over 9 is 0.1 infinity. Kind of interesting. He's the first infinity number that's repeating. 7 was repeating, but it's 6 different numbers. Because 7. 6 is repeating. You've got that 1 in there, but it's just a bunch of 6s after that. 9 is another repeating 1, 1, 1, 1, 1. But he's not himself the same way that 3s and 6s are. So 9's kind of interesting. Yeah, he's special in a lot of ways because he's associated with squares and circles again, just like our 6. Our 6 is even, but also a circle. Our 9 is a square, a perfect square, and the father of all trigonometry. 9's got it going. So like I said, 8, he's got a steady future ahead of him. 9, he's got a steady future ahead of him. You know what I mean? Like, they've grown up from the time they started at 1. They start at 1, and they go through, they go through school from 6th grade until graduating at 10. And you start at 2, and 2 builds up into an 8. Cool. You move up to 3, 3 moves up to a 9. Cool. So I mean, like, you watch them grow. They're growing up. They really are. They're growing up. And then you got 10. 10 is your decimal system. 10 is the most stable. It's 2 times 5. Prime factors of 2 are stable. Prime factors of 5 are stable. 2 times 5 is 10, making him the most stable number. 10 is the most stable number, which is why we have our entire number system is decimal. It's all base 10. 10 is the end and the beginning. It's graduation. You just graduated high school. You finished school, but guess what? Now you get to start your life. You get to start college. You get to go do whatever you want. Because 10 is the end and the beginning. The end of high school, but the beginning of your life. Everything builds on him, and he's best friends with 5 and 2. You can draw him as 2 intersecting pentagrams. I prefer just 1, 0. I think that I'm going to get into that in the next one. The interior angles move up. So 9 was 140, the interior angle. And then he's only 140.4. Like, how interesting is it to watch how the interior angles change? From 60 to 90, that's plus 30. Okay, we have a 30, the numbers between 60 to 90 is 30 different from here. But you're going to watch each other, they get smaller. From 90 to 108, well, guess what? It's only 28. From 108 to 120, well, guess what? That's only 12. We can't do anything with 7, because fucking 7, But 120 to 135, now it's only 15. 135 to 140, well, that's only 5. 140 to 140.4, that's only a 0.4 difference. So the difference in the interior angles gets smaller and smaller and smaller as it goes up, because eventually they're going to create a circle. That's how they first figured out pi. It's because you just keep adding angles to polygons. Anyway. Yeah. 10 is not a cube. 10 is not a circle. 10 has 5 sums. 5 plus 5 is the biggest one. And 10 is composite. 1 times 10 or 5 times 2. None of these numbers have any products more than just 2. It is either times 1 or it is either times 2. 2 times 2, 2 times 3, 2 times 4, 3 times 3, I'm sorry. Look at him, because 3, he's got to be in there somewhere. 2 times 5. So I'm sorry, I was wrong on that one. 3, he comes in clutch. He's in a clique with 3, 6, and 9. What can I say? Yeah. These are your numbers. They're your friends. They all have something special about them. They all have a dynamic. And if you ask me, they all have a feeling. I ask myself, what does 2 feel like? And to me, I remember when I was a child in kindergarten or first or second grade or whatever, where we're learning how to count. And I remember feeling like, man, 2. I can remember 4 because 4 is just 2 plus 2. And I had like this feeling inside. And I can remember 6 because 6 is just 3 plus 3, So like going back to that feeling, and then 5s were just stable. Because when you're learning how to count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You don't even got to think about it. It's just 5, 0, 5, 0, 5, 0, 5, 0, 5, 0. You ain't got to think about it. 2s are easy. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. 22, 24, 26, 28, 30. It's just 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. 2s are like easy as hell to remember. Once you get to 7, fuck, I got to think about it. Wait a minute, 28 plus 7? Wait a minute. Hold on, I gotta think about that for a second. Because 7s, man, they're not gonna be easy. They're gonna stand out. That's what I mean. They all have characteristics. Some of them are square, some of them are circle. 7, the first irrational number. We've got 1, 2, 3, 4, 5 prime numbers. 6 is your first perfect number. We've got 2 platonic solids coming out. I think an octahedron. Oh yeah. And the cube. Dang, never mind. We got 3 platonic solids. I'm sorry, I correct myself. Tetrahedron, cube, and octahedron, I believe. And then the isosahedron and the dodecahedron are also platonic solids. Yeah. Getting to know your numbers, because they all have personalities, and it makes working with them so much easier when you know what they feel like and not just what you think that they are. Alright, my next video, I'm getting into it because I'm actually rewriting mathematics from the beginning. I'm changing what even and odd are defined as, basically. In my style of mathematics, 5 and 2 are the only even numbers, and everything else is odd, basically, because we're going to be building on what is finite and what is infinite instead of even and odd. Even and odd are characteristics of numbers, but we let that define everything about the number, and that's a mistake, because that's a man-made idea versus paying attention to the behavior of the number itself. When you pay attention to the behavior of the number itself, our current system of mathematics is wrong. So I'm rewriting mathematics from the beginning. So if you're interested, Spiral Dynamics 102 is the next lesson that I'm going to be doing a video for with this same exact chart. I'm going to end this video and I'm going to start the next one because we're redefining what a number is. Yeah, it's going to be exciting. I made this breakthrough last night, and I'm totally excited to talk about it. Love you. Have fun. Deuces.